Rahim. Question number 2, part number 2, exercise 2.2. The question is, A is a matrix having elements in the first row are -1, -2, -3, and B is another matrix having elements in the first column is 3, -2, and 1. The order of the matrix A is 1 cross 3. There is one row and 3 columns, and the order of the matrix B is 3 cross 1. There are 3 rows and 1 column, and we have to multiply the matrix A with the matrix B. The condition for the multiplication of the matrix A with the matrix B is satisfied. That is, there are 3 columns in the first matrix and 3 rows in the second matrix. The condition for the multiplication is satisfied, and we have to multiply the matrix A with the matrix B. The procedure for multiplication is multiply the first row with first column. That is, multiply -1 with 3, plus -2 with -2, plus -3 with 1. This resultant element is -3 plus 4 -3. The resultant element is equal to -2. The order of the resultant matrix is 1 cross 1. There is 1 row and 1 column, and after the multiplication of the matrix A with the matrix B, the resultant matrix having element is -2 in the first row and first column. There is an important point in the multiplication of two matrices. Let A be a matrix of order m cross n. That is, A is a matrix having m rows and n columns. B be a matrix having order n cross p. Then AB is possible. That is, the columns of the first is equal to the rows of the second. That is, the column of the first is equal to the rows of the second. So multiplication is possible, and after the multiplication as explained in counter example, we get a resultant matrix C. The order of the resultant matrix is equal to the rows of the resultant matrix will be equal to the rows of the first matrix, and the column of the resultant matrix will be equal to the columns of the second matrix. So in this case, the order of the resultant matrix is 1 cross 1. There is 1 row which is equal to the row of the first matrix, and there is a 1 column which is equal to the column of the second matrix.